We live in a world that passes through a phase defined by a rapid growth in technology that transforms our lives and our communities for the better. The University of Moratuwa, which is considered the most prestigious institution of higher education in Sri Lanka, pioneers the Sri Lankan contribution to technological endeavours worldwide and prominently marks our place in the ever-changing global technological landscape. The University of Moratuwa traces its roots to over a century. Originally established as a technical education institute in the heart of Colombo in 1893, it took residence in Katubadda in 1959 and obtained the university status in 1972. With an innovative and enterprising approach, superior standards in research and development, and high employability rates for its graduates, it is one of the most sought-after universities in South Asia. The unmatched student selection standards and a unique set of courses coupled with an unparalleled learning experience make its graduates highly reputable in both national and international stages. All of its undergraduate degree programs are honours programs that span for 4 to 5 years, and they provide the students with rigorous knowledge and a well-crafted set of skills that would be instrumental for their professional and personal development. The University of Moratuwa houses the Faculty of Engineering, Faculty of Information Technology, Faculty of Business, Faculty of Medicine, Faculty of Graduate Studies, and the Institute of Technology. The degree programs offered by these faculties and institutions are approved by the University Grants Commission in Sri Lanka and are accredited by national and international organizations. The Faculty of Engineering is the largest faculty in the University of Moratuwa, comprising 12 academic departments with about 200 academic staff and around 4,000 undergraduate and postgraduate students. The faculty at present offers honours degree of Bachelor of the Science of Engineering degree in 9 disciplines, honours degree of Bachelor of Design in Fashion Design and Product Development, and honours degree of Bachelor of Science in Transport and Logistics Management. Academic disciplines offered for BSc Engineering degree include Chemical and Process Engineering, Civil Engineering, Computer Science and Engineering, Earth Resource Engineering, Electrical Engineering, Electronics and Telecommunication Engineering, Material Science and Engineering, Mechanical Engineering, and Textile and Apparel Engineering. In addition, the faculty offers many postgraduate courses and research degrees in various engineering and allied disciplines, leading to Master of Science, Master of Engineering, Master of Philosophy, Master of Business Administration, and Doctor of Philosophy. The Department of Electronics and Telecommunication Engineering of the University of Moratuwa has established itself as a pioneering academic institution in the nation, offering an exceptional academic environment which enables students to reach their fullest potential. It is greatly supported by the contributions of its high-caliber qualified academic staff with diverse areas of expertise, carefully designed outcome-based curricula, learning-friendly environment focused on state-of-the-art technologies and research, and well-received experience from its exceptional student body. In April 2003, the department moved to its new building from the earlier location in the Sumanadasa building. As a majestic 4-storied building located to the east side of the university premises, the current premises of the Department of Electronics and Telecommunication Engineering comprises of 9 fully equipped laboratories, 3 industry-sponsored research laboratories, and provides a common space for studying, engaging in projects and recreation, and many more facilities to nurture a student learning-friendly environment. The department has 4 main lecture halls, namely ENTC 1, PG Seminar Room, 3.5L Hall and 3.5R Hall, where students can comfortably attend to their respective academic activities, housing around 400 students each year. The common area and the open common areas allow the students to relax and engage in their spare time, joyously interacting with their colleagues. The department makes a consistent effort to improve its facilities each year, and the newly established Biomedical Engineering Laboratory and the approval of a grant for a Facilitation Center for Advanced Electronics Design are results of such efforts. The senior academic staff of the department has had specialized training both locally and abroad at well-recognized institutions in fields of study such as physical and optoelectronics, medical and industrial electronics, optical communications, satellite communications, digital communications, wireless communications, VLSI design, signal processing, electromagnetics, robotics, intelligent systems, machine vision and learning, pattern recognition, avionics, medical imaging and instrumentation, biomedical systems, and many other important areas related to the core disciplines of the department. Since its inception in 1969, ENTC has been an instrumental establishment of the nation, nurturing over thousands of highly sought-after graduates who have excelled in their academic work and whose exceptional achievements speak volumes of a legacy spanning for over 50 years. The University of Moratuwa attracts the top performers from the countrywide advanced level examination, and from this group of highly talented students, ENTC attracts the top performers from the Semester 1 examinations each year. In the year 2014, the department introduced its biomedical engineering specialization, becoming the first ever state university department to introduce an undergraduate biomedical engineering program. Currently, the department offers these two highly sought-after specializations, BSc Honours in Electronics and Telecommunication Engineering and BSc Honours in Biomedical Engineering, to approximately 120 students each year. ENTC also offers taught graduate degrees in Telecommunications, Electronics and Automation, and research degrees leading to the award of MSc, MPhil, and PhD. Students experience a technologically advanced, conducive, and friendly environment at the ENTC. Our approach is inclusive, supportive, and respectful of diversity. Laboratories equipped with modern instruments and industry-standard software make students ready for professional work. Students organize exhibitions, industry forums, and talent shows, inculcating harmony and leadership. The students foster a sense of social responsibility, manifested through activities such as the eCare Community Service Program, one of many activities of the eClub, the student organization of the department. Students greatly benefit from this fruitful life experience the ENTC family offers. Many diverse modern tools are being utilized in ENTC curricula. For example, Mentor and Synopsys tools for teaching electronics design, use of NumPy and TensorFlow for teaching computer vision and pattern recognition, using Robot Operating System for teaching robotics, and the use of Fluke biomedical testing equipment for biomedical electronics. The department also has various programs to provide sustainable academic support for the students, where its staff-oriented mentoring program ensures students receive the proper guidance early in their student life. Few of the staff members who serve as university student counselors are also available for consultation for the students. In addition to all these academic support programs, the department makes it a responsibility to work closely with the Engineering Faculty Quality Assurance Cell and is very committed to ensure and enhance the quality of undergraduate academic programs it offers. Our graduates recurrently go on to become skilled engineers in top electronics, telecommunication, and computing firms around the country and the world to push the boundaries of industry. Concurrently, many of our alumni go on to pursue graduate studies in world-renowned universities and become esteemed researchers and scholars.
Welcome to the virtual lab tour of the Electronics and Telecommunication Department. Being one of the flagship departments in the University of Moratuwa, we hold a number of promising lab facilities housing many state-of-the-art equipment. Let's first look at the three core laboratories: Analog, Digital, and Telecom Labs. These three labs holds practicals for many core courses and are among the busiest labs within the ENTC. These are readily available for students from all levels to use for their experiments even in their free time. Let's first go into the Analog Lab.
The department's Analog Electronics Laboratory accommodates the analog electronics experiments for many courses. These include the laboratory classes related to EN1013 Electronics 1, EN2013 Electronics 2, EN2110 Electronics 3, and EN4213 Power Electronics, as well as EN1802 Basic Electronics and EN2852 Applied Electronics done for other disciplines. As such, this is one of the most occupied laboratories in our university. The laboratory has 20 workstations. Each station is equipped with a digital storage oscilloscope with appropriate probes, an arbitrary function generator, a digital multimeter, and a dual tracking power supply. Additionally, students are provided with analog multimeters, protoboards, and components appropriate for each laboratory class. Usually, A group of 3 students sit at each workstation. Students carry out experiments with the support of several junior lecturers. They individually evaluate each student. In addition to facilitating laboratory classes attached to course modules, this laboratory supports course projects. This laboratory received good feedback from students. Let's take a closer look at the equipment available in the Analog Lab. Each workstation is equipped with either Keysight 34450A or Keithley 2110 high-accuracy digital multimeter, which allows taking accurate readings. All the workstations are equipped with GW Instec AFG 2025 arbitrary function generators. This function generator has the ability to generate noise, rectangular, sinusoidal, triangular and arbitrary waveforms with frequency up to 25 MHz. Therefore, students have the capability to perform experiments with various inputs and conditions. Each workstation is equipped with Tektronix TBS 1052B, 2-channel digital oscilloscope. This oscilloscope has a bandwidth of 50 MHz with a 1 GP's sampling rate. In addition to that, this device has a USB interface to connect with a computer, which enhances the analyzing of the waveforms. Each workstation is equipped with Keithley 2231 ADC power supply to fulfill the power requirements of the experiments. Due to the independence of each channel, this device allows generating dual power required for the circuits with a large effect. In addition to providing the power, the current limiting capability ensures safety from burnouts and other failures of the experiments. These are the type of equipment available to our students in the Analog Lab.
Next up, Digital Lab.
The Digital Electronics Laboratory is the counterpart of the Analog Electronics Laboratory and as such, accommodates the digital electronics experiments for many courses. These include the Digital Electronics Laboratory classes related to EN 1013 Electronics 1, EN 2013 Electronics 2, EN 2110 Electronics 3, EN 3030 Circuits and Systems Design and EN 4063 Digital IC Design. It additionally hosts EN 1802 Basic Electronics and EN 2852 Applied Electronics done for other disciplines. This laboratory also consists of 20 workstations equipped with a mixed signal oscilloscope with appropriate probes, an arbitrary function generator, a digital multimeter, and a DC power supply. Like the Analog Electronics Laboratory, students are provided with a multimeter, protoboards, and digital components needed for each lab class. A group size of 3 is maintained so that each student gets sufficient first-hand experience and can be evaluated individually by a junior lecturer. Students are also provided with Altera FPGA boards needed for design projects. They are only required to return the boards when the semester ends. This gives ample opportunity for experimentation, testing, and debugging. Let's have detailed overview of the equipment available in the Digital Lab. CPX400 SADC power supply is capable of providing up to 60 volts and up to 20 amps. Students find this is very useful in all the practicals due to its user-friendly nature. One limitation of this series is that it is a single-channel power supply. In some practicals, students have to work with different voltages such as 5 volts and 12 volts with their negative voltages at the same time. In such scenarios, we can use the Keithley 2231 A33 DC power supply. This power supply is equipped with 2 channels capable of providing 30 volts with 3 amps and 1 channel with 5 volts with 3 amps. This function generator is capable of providing waveforms in the frequency range of 1 microhertz to 60 megahertz, with a frequency resolution of 1 microhertz. Students are free to choose 6 standard waveforms including sine, square, triangle, DC, etc., and 26 arbitrary waveforms such as Hamming, Gaussian, Trapezia, Tan, etc. It comes with 2 output channels. Function generator plays a key role in many practicals. The user-friendly interface of the function generator makes easy to use and flexible of tuning parameters such as amplitude, frequency, etc. The Tektronix DMM4020 digital multimeter at the Digital Electronics Laboratory comes with following specifications. A 200 mV to 1000 volts voltage range, with up to 1 microvolt resolution. A 200 microampere to 10 A current range, with up to 1 nano A resolution. A 200 ohms to 100 mega ohm range, with up to 1 milliohm resolution. This tool is heavily used by students for debug their circuits. The Tektronix MSO2024B mixed signal oscilloscope comes with 4 channels, with 200 MHz bandwidth. This device plays a central role in analyzing waveforms. Having multiple channels helps students to compare waveforms taken from different points of the same circuit and perform some operations like adding, inversing waveforms. 3-bit up, down counter to 7-segment LED display, microcontroller programming, and digital design with FPGA are few of the practical conducted in the Digital Lab. These practicals start with basics, such as reading datasheets and identifying a given logic IC, working with flip-flops, and integrating the 7-segment LED display to display the output. In microcontroller programming, we introduce students to microcontrollers by allowing them to identify a microcontroller's internal structure and peripherals. Then, we gradually move to a design problem to challenge our students. In digital design with FPGA practical, we introduce students for FPGA and challenge students with the same design problem to implement in FPGA.
Finally, the Telecom Lab.
Welcome to the Telecom Lab at ENTC. The Telecom Lab at ENTC provides the home to many experiments from different courses including the EN1092 Laboratory Practice 1, which includes the laboratory classes related to EN1053 Introduction to Telecommunication, EN2030 Fundamentals of Computer Organization and Design, and EN2560 Internet of Things Design and Competition. As one of the most occupied laboratories in our university, Telecom Lab is equipped with 20 workstations, each consisting of a Rode and Schwartz HMF2525 arbitrary function generator, a Tektronix TBS1102B digital oscilloscope, a digital power supply, and an MS2661C spectrum analyzer. These are the DL2402 color TV trainers. Each comes with an individual PCB for each stage, providing the opportunity for students to get familiarized with the circuitry of modern TV receivers. We divide our students into groups with 3 students per group, providing sufficient space for each student to get hands-on experience. Apart from this, all the components, multimeters, and protoboards are supplied for every practical. Students carry out experiments with the support of several junior lecturers. They individually evaluate each student. We have designed laboratory workbooks and manuals and distributed them at the beginning of a session. We also provide multimedia facilities and whiteboards to deliver the lesson more effectively for the students. We have given freedom for students to use laboratory facilities at free hours, and students find this is very useful. Now let's take a closer look at the equipment found in the Telecom Lab. Rode and Schwartz function generator is one of the key equipment found in a workstation of the Telecom Lab. These are capable of generating sine, square, pulse, triangle, ramp, and many other arbitrary waveforms such as white noise and cardiac. They can generate waveforms from 10 microhertz to 25 megahertz with an output peak-to-peak voltage varying from 5 millivolts to 10 volts. This equipment is utilized in many practicals conducted in the Telecom Lab. Another important piece of equipment found in the Telecom Lab is the Tektronix TBS1102B digital oscilloscope. This has a bandwidth of 100 megahertz along with 2 channels with a sampling rate of 1 giga samples per second. This is mainly used by students for analysis and visualization of the signals generated by the various circuits built by them specially for FYPs. One of the most common pieces of equipment found in our labs is the DC power supply. Each workstation in the Telecom Lab is composed by one of these Siglent SPD3303 DC power supply. This supports programmability and real-wave display and is mainly used by students for testing their electronic circuits utilizing its 3 channels capable of providing up to 32 volts and up to 3.2 amperes. The MS2661 spectrum analyzers are the most valuable pieces of equipment within the Telecom Lab and is mainly used for analyzing electrical input signals and spectral compositions of signals. Now let us look at a few practicals conducted in the Telecom Lab. As a practical component of EN1053 Introduction to Telecommunication, students are given the opportunity to understand various channel characteristics by realizing them using simple discrete resistor, capacitive and inductive units. Students find this a good experience to gain an intuitive understanding of how these channels behave. As a practical component of EN2030 Fundamentals of Computer Organization and Design, students realize various memory components such as SRAMs and DRAMs with the use of basic components such as MOSFETs. This helps the students to understand the underlying principles of computer design. For EN2560 Internet of Things Design and Competition, students conduct various practicals on Node RED, Node MCU, MQTT and many more. Therefore, Telecom Lab is one of the core laboratories in the ENTC open up to all levels of students.
The next set of labs we will be looking at are the Intelligent Machines and UAV Laboratory, Optoelectronics Laboratory and Microwave Laboratory. These labs are involved in the development of UAVs to robots and involved in many experiments related to microwave and optical communication. Let's first look at the Intelligent Machines and UAV Laboratory.
Welcome to the UAV Laboratory of ENTC. This lab facilitates full-cycle development of UAVs from sketch to reality. The UAV laboratory has more than a decade-long history going back to late 2000s, where a small group of students started building a quadrotor UAV for their final year project under Professor Rohan Munasinghe's supervision. Under his leadership, the journey started there has now come a long way and now houses many state-of-the-art machinery such as this 3D printer from Ultimaker, which is actively used for rapid prototyping of drones. This lab is also equipped with an industrial-grade CNC machine and laser cutters, which are mainly used for developing molds and internal structures of UAVs. Thermal forming machine is also a valuable asset among the lab's equipment collection. Thermal forming machine along with custom developed molds can be used to create complex 3D shapes with better aerodynamic properties. Covering mold, fuselage, and structure manufacturing and PCB assembly for control unit manufacturing are few of the tasks facilitated by the UAV lab. Resources are not only limited for the manufacturing aspect of UAV development but also for designing, such as modern workstations with state-of-the-art software such as SolidWorks, Altium and ANSYS CFD for UAV simulation. Let us look at UAVs made at UAV Laboratory of University of Moratuwa. Hornet is an UAV with vertical takeoff and landing, VTOL, capability. This kind of an UAV is quite useful when terrain is not suitable for conventional fixed-wing UAV operations, which requires a large amount of flat land for a runway. Raven is the first long-range UAV built at the laboratory. With a gasoline engine for higher flight time. Intelligent Machines Laboratory is the Siamese twin of the UAV Lab and is open up to the same set of resources and equipment as the UAV Lab. This laboratory is mainly used to handle robotics and automation-related activities. It houses development boards for power devices, microcontroller testing and other devices such as multitude of sensors and mechanical equipment. In EN2532, Robot Design and Competition module, the students learn fundamentals of robot theories as well as involve in designing real robots. The competition allows the students to engage in a thrilling experience as they cheer their robots to the victory. The competition structure is different in each year and it is conducted either indoors or outdoors. The department provides Pololu DC motors for all student groups who are enrolled in the module as well as laboratory training on how to use them. Each lab is conducted for a group of 5 students with hardware resources including various types of robotic sensors and actuators. EN3143 is Electronic Control Systems module where the students learn theories such as PID control. EN4563 Robotics module teaches students about underlying mathematical concepts of robotics such as spatial transformations, kinematics, and motion planning. The students get the exposure to state-of-the-art tools such as Robotics Toolbox and Robot Operating System, and how to use them in their projects. Through EN4593 Autonomous Systems Laboratories, students learn the autonomous concepts such as state estimation, linear and nonlinear filters, and localization and mapping algorithms such as SLAM. There are 15 units of Pololu Zumo robots available for students to get hands-on experience in understanding wheel odometry and developing filters like Kalman filters. Inspired students who pursue final year projects in the field of robotics can use facilities such as legged robot research indoor arenas to gather repetitive data and improve their robotic designs.
Next, the Optical Lab.
Welcome to the Opto Laboratory of the Electronic and Telecommunication Department. This laboratory is equipped with the most advanced optical fiber tools, which allow students to gain industrial-level experience with in-depth study of optical fiber communication systems. This laboratory facilitates all the practical experiments for the EN4323 Optical Fiber Communication Module. Practical work related to the module contains measurement of fiber loss, attenuation and connector cleanliness using optical time domain reflector, optical fiber splicing, study about optical fibers and their attenuation, study about the optical source and their characteristic and familiarization to VPI transmission maker software. In addition to that, students are allowed to do any optical fiber experiment in this lab. Let's have a brief overview of the equipment available. Opto Laboratory is equipped with the Max Tester 720C MAX720C. This device provides first-time right fiber characterization due to its short dead zones and effective dynamic range. This device is optimized for single-mode and multi-mode field testing. Further, the MAX720C includes a power meter, a visual fault locator, Wi-Fi connectivity and high-resolution inspection capabilities, which enhance the experimental capabilities. This is a Fiddle Furukawa Electric S178A Fusion Optical Fiber Splicer. Therefore, students are available to connect their fibers as required for the experiments. In addition to that, all the students get hands-on experience with fiber splicing under the optical fiber module. Here is a Thorlabs CLD1015 laser diode and temperature controller which can drive and cool the pigtailed butterfly laser diodes. This device allows students to drive their laser diodes required for their experiments. In addition to that, students have to drive different diodes and measure their characteristics using this driver under the optical fiber module. This is EXFO FIP435B Fiber Inspection Probe. This device features Wi-Fi connectivity, one-step pass, fail function, automated focus, triple magnification, auto center and connector end face analysis, IEC, IPC or custom standards, including MPO, MTP. Therefore, students can get industrial-level hands-on experience and they can debug their systems. Opto Laboratory is also equipped with various optical power meters including Thorlab PM20CH. Students get hands-on experience with these optical power meters under the optical fiber module. However, this equipment is allowed to be used for any experiments. We also have different laser diodes including Thorlab, FPL1053S 1310 nanometers and Thorlab, FPL1009S 1550 nanometers. These diodes provide students to get experience with laser optical communications and understand basic laser characteristics. This is a Anritsu MS9710C optical spectrum analyzer. This allows students an in-depth study of optical fiber systems and their characteristics. Students get hands-on experience with this instrument under the optical fiber module and students are allowed to use these for their experiments. Thus, our students are equipped with the best equipment to carry out their research and studies in optical communication.
And next up, Microwave Lab.
Welcome to the Microwave Laboratory of the Electronic and Telecommunication Department. This laboratory facilitates in-depth study about microwave communications. This laboratory is equipped with spectrum analyzers, microwave sources and the waveguide training kits. In addition to student research and experiments, this laboratory provides practical experiments for microwave communication modules. Those experiments include demonstrations of waveguides, microwave propagation and microwave antennas, and in-depth study about interference between the direct and reflected waves, attenuation due to ferrite and basic ASK modulation.
Next, let's take a look at the facility which hosts the largest variety of equipment, the ENTC Workshop. This one of the most lively labs in the ENTC.
This is the ENTC Workshop. Our workshop houses lots of necessary equipment required to successfully complete a student electronic project. This workshop is used by students of all levels from first year to postgraduate level and therefore holds a multitude of equipment required for testing and debugging electronic projects. Let's have a closer look at these equipment. Function generator. This is mostly used for testing low-frequency analog circuitry, such as amplifier circuits, audio circuits, switching circuits and RF circuits. It can supply several types of waveforms with varying voltages up to 20 MHz. Oscilloscope. This equipment is used for observing electrical signals, waveforms in both digital and analog circuitry alike. Can display waveforms up to 100 MHz frequency. This is sufficient for debugging non-RF circuits. Digital multimeter. This equipment is used to quickly probe relatively low voltage, current AC and DC circuits to measure voltage, current and resistance values. Regulated DC power supply. Provides stable user configurable DC voltage supply, overcurrent protection to safeguard the circuit and the equipment when debugging. SMD rework station, used to assemble and debug printed circuit boards with surface mount devices. Microscope camera. To handle electronic components with very small packages and to debug and observe soldering quality after PCB assembly. This is a student project, programming a large LED panel to display information. 3D printer. This enables students to make prototype enclosures for their projects, which enable the students to experience complete electronic product development. Four-channel oscilloscope enables students to debug mixed signal circuits with higher complexities. Digital power meter to measure power consumption, output, and efficiency of electronic circuits, especially used to develop power electronics projects. Solar array simulator, especially useful when developing efficient inverter technologies for solar panels. DC electronics load enables to test power electronics applications such as power supplies, batteries, inverters, and regulators easily and safely. 720W power supply. This is used to supply power to DC electronics applications which uses higher amount of power such as high-power motor controllers, DC-DC converters, high-power battery systems, and other high-power electronics applications. Polyphase watt meter is used for measuring the power of a polyphase circuit. For an example, three-phase circuit. AC ammeter, voltmeter, for measuring voltage and current of AC circuits. LCR meter, used for inductance, capacitance, and resistance measuring. This is a crucial piece of equipment for antenna design. Voltage, current, and ohm calibrator, used to calibrate sensor systems and measuring equipment. Lux meter, used to measure light intensity at a location, mainly used to measure performance of lighting equipment and to calibrate lighting for vision systems. Sound level meter, used to measure performance of audio systems. High voltage probe, a portable device to measure high voltage systems, lines. AC-DC current probe, a portable device which can be used to measure current in wires. FM/AM generator. This is used to generate varying FM/AM signals with different power and frequencies to be used to simulate RF circuits. station with large range of nozzle types. Enables easier soldering or desoldering of large electronic component packages. Thus, housing this many state-of-the-art equipment ENTC Workshop can be considered of the most crucial facilities among many others that is available for our students.
Next, let's have a look at the latest addition to our lab facilities, the Biomedical Lab.
Welcome to the Biomedical Engineering Laboratory of the department, one of our most recently established laboratories which accommodates for all the requirements of the biomedical courses of the students. For the courses such as BM2011 Human Anatomy and Physiology 1 and BM2020 Human Anatomy and Physiology 2, there are many anatomical models available for teaching purposes. Students are encouraged to study the internal structures of these models by disassembling them. Furthermore, the laboratory provides computer workstations for students to work with the courses of BM4151 Biosignal Processing, BM4301 Medical Image Processing and BM4321 Genomic Signal Processing. The lab also houses 2 Philips clinical multi-parameter patient monitors with state-of-the-art sensors that measure the vital biosignals of the human body. The second monitor is set up next to a bed where the subject can lie down and be hooked up to the monitor. The multi-parameter monitor is capable of recording ECG, blood oxygen and respiratory rate of the subject connected to it, giving the medical caregivers information about the vital biosignals. Studying about cell biology and biotechnology in courses like BM4620 make use of the Optica microscope and the pre-prepared zoology slides as well. Students will be wearing lab coats while handling the microscope and doing the necessary observations. The Fluke Electrical Safety Analyzer is available for studying electrical safety principles. Think Lab's digital stethoscope is a great example of an innovation that uses both biomedical and electronic engineering principles. One of the most important resources in the lab is the BioPack MP36 system. Students are given the opportunity to complete all the important physiological experiments connected to the human body using the BioPack system. To study some of the important principles covered in BM4111 Medical Electronics and Instrumentation, the lab also consists of an AD Instruments Octal Bioamplifier setup for amplifying biosignals and digitizing them to analyze and record on the computer. Finally, The Fluke Virtual Science Simulator as well as the EEG headcaps are quite useful for studying more about acquisition and processing of biosignals. All these resources facilitate the learning of biomedical undergraduates at the Department of Electronic and Telecommunication Engineering. Let's look at some of the experiments and practicals done in the Biomedical Lab. Here you can see instrumentation amplifier circuit design for ECG signal acquisition from BM4111 Medical Electronics and Instrumentation. These are the BioPack MP36 lab experiments for BM2011 Human Anatomy and Physiology I, BM2020 Human Anatomy and Physiology II. These are the optical microscope cell structure visualization and observation experiments for BM4321 genomic signal processing. And finally EEG signal acquisition using AD Instruments Octal Bioamplifier for BM4151 biosignal processing.
Next, let's look at some of the industry-collaborated labs. The synergy formed from the industry links of the Dialogue Lab and the Premium Lab help introduce the state-of-the-art facilities to our curriculum while outputting innovative research beneficial to the society.
The Dialogue, UOM Mobile Communications Research Laboratory is specialized in applied research in mobile telecommunication technologies and Internet applications. The activities of the research laboratory focus on stretching the frontiers of applied mobile technologies through research and development pertaining to initiatives of national and regional significance. This is the first fully industry-sponsored research laboratory to be established in a university in Sri Lanka. Also, it is the country's first laboratory for research and development in mobile communications. Our smart energy meter, which is an IoT device with a novel prepaid metering facility, has now been deployed by the partnering company Lanka Electric Company at over 3,000 locations. Imani is another innovative system deployed by this lab. This industrial monitoring system is in use at over 200 mobile network-based stations. The Smart Button, the Smart Socket are a few other products of this lab. These products add value to telecom networks, improve the standards of living of people, and contributes towards advancing the industrial sector. Experiences gained through this partnership with Dialogue helps introduce state-of-the-art content into the department's curriculum.
Next, the Premium Lab.
This is the Premium International University of Moratuwa R&D Laboratory for Biomedical Technology. Premium has collaborated with the University of Moratuwa to set up Sri Lanka's first ever R&D laboratory for biomedical technology. This pioneering venture was initiated to harness the engineering expertise available locally and to provide a platform on which to conduct research on par with international standard with a view to commercialize identified technology. This landmark public-private partnership agreement between Premium International and Sri Lanka's top-tier tertiary institution for engineering, the University of Moratuwa, resulted in the establishment of Sri Lanka's only R&D laboratory for biomedical technology. The laboratory has successfully completed clinical trials and awaiting commercialization of the first medical device researched and developed in Sri Lanka, the pulse oximeter.
The last set of labs are the Vision Laboratory, Computer Laboratory and the Postgraduate Laboratory. The Vision Laboratory is involved in many deep learning-based researches. The research assistants working in the lab have full access to GPU servers, enabling them to engage in state-of-the-art research. Currently, the department does not provide personal computers, but virtual servers with required computational power and memory can be obtained for undergraduates, postgraduates, and staff researchers from the Center for IT Services, commonly known as CITES. These servers are capable of running a variety of operating systems. If a server is required for an undergraduate project, the server is allocated for their supervisor. The postgraduate laboratory is involved in many advanced researches in the fields of electronics and telecommunications and has all the necessary facilities to bring out the maximum potential of our postgraduate students. This ends our virtual lab tour.
In addition to the many top-notch lab facilities available in ENTC, we holds variety of licenses for top-tier software tools. Expensive software tools are used in the industry to design cutting-edge designs. To familiarize our students with the design and development process, we have purchased the licenses for several such software. Students and staff use the tools in practical sessions and to do research work and publish in international journals and conferences. Also, startups incubated in the university use them for prototype development. We have 10 licenses of Altium Design Suite, the industry standard tool to design printed circuit boards. Students, from level 1 onwards, are able to design PCB schematics, multi-layer PCB layout and simulate them as well. We have 100 licenses of SolidWorks available for all departments in the university server. Our department students and startups design and build enclosures for product prototypes such as biomedical wearables and embedded systems, 3D print them and manufacture them too. Ones who pursue robotics create models and use them in robotics simulators such as Gazebo and later manufacture them too. We have 2 machine lock licenses for VPI Photonics Suite. Beyond electronics, VPI Photonics is an end-to-end tool to design, verify and sign off photonics designs. Students use them to design fiber optic systems in practical sessions and gain valuable intuition. Field programmable gate arrays are essential in introducing digital design techniques and to implement digital signal processing algorithms. We have several cutting-edge development boards from Altera and Xilinx. Vivado System Edition and other Xilinx tools are used by students and research assistants to build processors, accelerators, network routing solutions and video encoding, decoding solutions. Many of these designs have been published in world-class journals and some have been commercialized through the university, which have resulted in startups that have formed a digital design industry in Sri Lanka. Altera is the second largest player in the FPGA market, after Xilinx. We have several boards of Altera boards and their software tools, which are used in several laboratory projects. VLSI or ASIC design tools are available to design and build digital integrated circuits. Tools in the Cadence family are used to pass Verilog RTL designs through DRC checks, synthesize them into netlist, insert DFT, place, route, get layout with area, power and frequency estimate. They are used in practical in digital IC design module of the final year for students to get familiar with front-end DICD development. Several students have built ICs using these tools and fabricated them in Japan and demonstrated as their undergraduate thesis project. Analog IC design and mixed signal designs are arguably the most difficult part of electronic design. We have the Cadence family of mixed signal tools to design, verify, place, route designs to be fabricated in fabs. These tools are used by students in final year who specialize in digital and analog IC design.
Apart from the resources at the department, the students also have access to the common resources provided by the university. During the first semester, all the students use the Level 1 Computer Lab of the Department of Computer Science and Engineering for their practical classes. These practical classes are held in groups of approximately 70 students, and the students are encouraged to use the computer facilities whenever the lab is free. The university provides a fully fledged library to all the students in every department. The library has an arsenal of books, examination past papers, journals, all accessible and available to be borrowed by the students. The library maintains multiple copies of books that have high student demand, thus giving an equal opportunity to all the students in their quest for knowledge. The library offers more than 2,000 books related to the modules taught in the Department of Electronics and Telecommunication Engineering alone. The library also maintains an online reservation system which motivates the students to make the maximum use of their library facilities. The library provides access to international journals such as IEEE Explore, Science Direct, and ACM Digital Library. Access to these online journals has also been made available to any student logged into the University Wireless Network, which brings the library to their fingertips. LearnOrg is a student academic administration system which primarily maintains student records and provides access to the students as well as the staff. At present, the system allows students to register for new modules and manage the modules by providing the Add Job function. Moodle is a course management system through which the distribution and submission of continuous assessments are carried out for the courses. It is integrated with LearnOrg for authentication and enrollments, and it further gives students the experience of e-learning, which is in fact the current trend in university education systems around the world due to the COVID-19 pandemic. Center for IT Services, or CITES, is responsible for the university IT infrastructure, which includes administration of university network backbone, general server administration, and maintenance of common computing facilities. University IT Help Desk is supervised under the CITES technical crew. CITES offers technical support and solutions to all ICT inquiries from academic staff members, non-academic staff members, and students. The Health Center's primary objective is to provide healthcare services for resident students and the university community. In catering to primary healthcare needs, the Health Center operates fully fledged laboratory services, ambulance services, and a preventive healthcare service. Its staff comprising the Chief Medical Officer, medical officers, and other support staff are dedicated to catering to the healthcare needs of the university community, including the non-resident students and employees. All first-year undergraduate students are offered university accommodation either on the main site of the university or in a nearby hostel with the aim of helping to support the student experience by providing efficient and effective accommodation services and facilities. The university offers at least one full year of accommodation, and some hostels offer this for the entire duration of the degree. There are 4 main canteens and 5 other sales centers in the university. These conveniently located canteens serve a good choice of meals for a healthy diet at modest rates. The Physical Education Division provides numerous competitive and recreational sports as well as state-of-the-art gymnasium facilities. Students can select from a wide variety of sports such as cricket, rugby, rowing, badminton, basketball, athletics, weightlifting, hockey, and martial arts. The university playground provides space for practicing most outdoor sports. There are also badminton courts, a basketball court, and a boatyard used for rowing within the university premises. The Physical Education Division organizes sporting tournaments for freshers in several sports. It also grooms athletes to participate in inter-university and international competitions. The University of Moratuwa is one of the leading universities in the inter-university sports events. The Colors Award ceremony that is held every year rewards students who have excelled in sports. Open Air Theatre is a theatre located in the University of Moratuwa near the university playground. It is popularly known as the Lagan among students and drama enthusiasts. It was built according to the architectural style of ancient Greek theatres. The Faculty of Engineering at the University of Moratuwa attracts the students from the merit list who are the top performers in the GCE Advanced Level Examination in the Physical Science stream. Even within this group, the ENTC degree programs attract top performers in the Semester 1 examination, indicating the fact that the ENTC degree program has the highest student demand during the field selection. Student entry to the department is controlled solely by the Faculty of Engineering based on the performance of the applicants at the Semester 1 examination. The students of ENTC maintain their academic performance throughout the time they spend at the department, despite following one of the most rigorous courses offered by the Faculty of Engineering at the University of Porto. During their third year of study, the students have the opportunity to embark on an internship program to obtain real-life working experience and put into practice the theories and concepts they have learned during the previous semesters. Most students intern at reputed local and international firms, while a significant portion of students complete their internships at research labs and institutes in esteemed universities around the world. Each year, by the time they graduate, over 10% of students go on to attain first-class honours, and this percentage is among the highest ratios of first classes awarded by any department in the Faculty of Engineering. The graduate employability is nearly perfect each year, and most students receive job offers from reputed local and foreign companies and organizations even before they sit for their finals. These ENTC graduates constantly climb up the corporate ladder and become leaders of the industry locally and globally. The students who wish to pursue research or careers in academia have the option of joining the department as research assistants or junior lecturers after they graduate. Most of them go on to receive full scholarships from top-ranked graduate schools in the world to pursue their graduate studies in the areas of computing, telecommunications, electronics, and biomedical engineering. Besides academic activities, the students of ENTC enthusiastically engage in numerous research works and self-initiated projects under the guidance of the faculty members. Over the years, some of these research works have been presented and published in high-quality conferences and journals associated with domains such as computer vision, machine learning, signal processing, robotics, electronics, telecommunications, and biomedical engineering. This is a conspicuous indication that the knowledge and experience provided to the students by the ENTC is making them capable of pursuing fundamental and application-oriented research that can render significant contributions to respective fields of study. Simultaneously, the students of ENTC frequently receive various accolades at reputed local and international competitions that promote technological innovations. The students are excited to apply the theoretical knowledge and design thinking they have inculcated at the department into implementing solutions that can alleviate the pressing problems in the real world. These innovative concepts and solutions often get recognized at both national and international stages, bringing glory to the ENTC and to the university. The final year projects are a fitting platform for the undergraduates to make use of the theoretical and practical knowledge, design thinking, and technical skills they have gained over the preceding 3 years to find robust solutions to real-world engineering problems. The students have the freedom to shape the scope of their final year projects, encompassing a multitude of diverse research areas, including but not limited to embedded systems, signal processing, telecommunications, machine learning, computer vision, robotics, and biomedical engineering. The span of a final year project is generally 1 year, and groups of 4 students work towards realizing the goals determined in the beginning of the projects. The final year project groups are typically supervised by 1 or 2 faculty members, and there could also be external supervisors depending on the scope of the project. The groups of students regularly meet their supervisors to discuss the progress of the work, and the supervision rendered by the faculty members helps the students sharpen their research skills. Each year, almost all of the final year projects are completed on a high note with high-quality marketable products, patents, or research publications at reputed journals and conferences. Some students join the department as research assistants after they graduate to continue the research work their groups have carried out in the final year project. Simultaneously, some students tend to take an entrepreneurial approach and commercialize products they introduced at the end of their final year project. All in all, it is evident that the final year projects transform our undergraduates from students to skilled engineers and researchers who have the potential to solve complex problems in their respective disciplines. Apart from the academic activities, the students engage in many extracurricular activities both within and outside the department. Each student of ENTC is inducted to the Electronics Club, commonly known as the E-Club, which is the official student association of the department. The E-Club organizes various events that serve both the department and the society at large while providing a platform for the undergraduates to develop their careers. E-Forum is one such event where a common platform is created for the undergraduates, faculty, industry, government, and other relevant institutes to discuss the common challenges faced by the fields of electronics and telecommunication engineering. This caters to the requirement of gearing up to lead national development, exposing the skills and talents of the undergraduates, strengthening the relationship with the industry, and creating awareness about the industry. The Sri Lankan Robotics Challenge is an annual robotics competition organized by the E-Club. This event is a gateway for all those who are interested in robotics and automation to unleash their talents in the field before a much vast audience. Alongside with the Department of Electronics and Telecommunication Engineering, it has been a key partner in organizing the Zonal Competition of International Robotics Challenge (IRC), which is conducted as a part of the biggest technology festival of India, TechFest. The Electronic Premier League, or TPL, is the most awaited sports extravaganza of the department. It is held annually at the university grounds with the participation of the ENTC family. TPL is a friendly cricket encounter between all the current batches of the department and its academic staff. The purpose of this event is to enhance the bond among the department students while giving them the opportunity to enjoy life at the university. The Electronic Shuttle Fest is a badminton tournament that intends to develop sportsmanship and soft skills of the undergraduates in the department. Sports have been identified as a major factor that could help create a balanced personality. The annual event Abhina, organized by the E-Club, is a fun-filled talent show which attracts a great number of university students each year. It showcases the musical, singing and acting talents of the ENTC students and create a platform for them to enjoy their college days to the fullest. eCare, the department's main CSR activity, is about helping the students in a rural school that can benefit from the knowledge and skills of university students. It is a fun-filled and educational encounter for both the undergraduates and school students. Donating books, repairing computers, painting the school, and sharing a meal are all part of this exciting venture. Department of Electronic and Telecommunication Engineering offers an exceptional academic program which enables students to reach their fullest potential. This is due to the contributions of high-caliber academic staff, carefully designed curricula, focus on state-of-the-art technologies and research, and well-received student experience. The department offers two highly sought-after specializations, BSc Honours in Electronics and Telecommunication Engineering and BSc Honours in Biomedical Engineering. Furthermore, the pattern recognition minor and several undergraduate courses cater for a wide audience in the Faculty of Engineering. The curricula are carefully designed, current, industry relevant, and make the students reach frontiers of technology. In this respect, the department has identified the thematic areas of communications, reconfigurable and embedded systems, robotics and automation, computer vision and pattern recognition, and biomedical technologies as areas of advancement. Forward-looking and diverse academic staff with higher degrees from well-known universities around the world facilitate this endeavor. Their expertise includes electronics, embedded systems, digital design, optoelectronics, VLSI, telecommunication, wireless communication, signal processing, electromagnetics, antennas, robotics and autonomous systems, intelligent systems, machine vision and learning, avionics, medical imaging, and instrumentation. To foster research, the department offers MSc, MPhil, and PhD degrees. The taught MSc programs in telecommunication, electronics, and automation attract students from the industry. These education programs prepare students for challenging careers in industry and academia in Sri Lanka and elsewhere. Students experience a technologically advanced, conducive, and friendly environment at the ENTC. Our approach is inclusive, supportive, and respectful of diversity. Laboratories equipped with modern instruments and industry-standard software make students ready for professional work. The 5-storied building houses these laboratories and provides space for studying, engaging in projects, and recreation. Students organize exhibitions, industry forums, and talent shows inculcating harmony and leadership. The students foster a sense of social responsibility manifested through activities such as the eCare Community Service Program, one of many activities of the E-Club, the student organization of the department. The students greatly benefit from this fruitful life experience the ENTC family offers. The rich academic culture, research facilities, supportive environment, and qualified faculty members enable the Department of Electronics and Telecommunication Engineering to produce multifaceted graduates who excel in industry and research.